projects. In this video, we are going to explain about a project titled Deep Learning Based Image Recognition for Autonomous Driving. So now coming to the introduction part. Deep learning has become a game-changing factor in the realm of computer vision, transforming the landscape of image recognition applications significantly. Within the domain of autonomous driving, the incorporation of deep learning techniques plays a pivotal role in elevating the perceptual capabilities of vehicles. In autonomous systems, image recognition holds paramount importance, relying on algorithms' capacity to scrutinize and comprehend visual data with a level of complexity that evaluates human perception. Autonomous vehicles rely extensively on an array of sensors, including cameras, to continuously collect real-time information about their surroundings. Notably, deep learning models, specifically convolutional neural networks, that is CNN, have demonstrated exceptional proficiency in extracting intricate features from images. So now coming to the objective part for this project is to equip vehicles with a robust and advanced visual perception system. This technology seeks to evaluate and in some instances surpass the visual capabilities of humans, enabling autonomous vehicles to interpret and comprehend their surroundings in real time. The fundamental objective is to improve the safety and efficiency of autonomous driving by empowering vehicles to make informed decisions based on precise and timely recognition of diverse objects, obstacles, and environmental cues captured by onboard cameras. To analyze intricate visual data such as road scenes, traffic signs, pedestrians, and other vehicles, deep learning models, particularly convolutional neural networks, are employed. So now coming to the requirements part, here we have two types of requirements, hardware requirements and the software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this we have to import some of the packages like NumPy and Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and C1 for visualization are important. So now here next we have exploring the dataset object data from RoboFlow. Understanding and examining the dataset is crucial. In this case, the dataset originates from RoboFlow and likely contains object-related data. Exploratory data analysis, that is EDA, may involve inspecting data dimensions, distributions, and sample records. The next here we have installing the packages required for YOLO v5. Specific packages and dependencies related to YOLO v5 need to be installed to ensure that the model can be implemented successfully. Processing the data based on the YOLO v5 model and using HOG for SVM features extraction. So here in this, the data is pre-processed with the specific attention to preparing for the YOLO v5 model. For SVM, the HOG, which stands for histogram of oriented gradients, method is employed for feature extraction, enhancing the data suitability for this particular algorithm. Then we have building the model. Two models are mentioned, YOLO v5 and SVM. Both are likely being constructing at this stage. YOLO v5 is a deep learning model for object detection, while SVM is a machine learning model commonly used for classification and regression tasks. The next here we have training the model. This step involves training the models created in the previous step. Training a model involves presenting it with labeled data, allowing it to learn patterns and features. This is a critical step for achieving accurate prediction. The next here we have building the model with YOLO v5. This step might involve further details about the construction and configuration of the YOLO v5 model. It seems to be reiterated from step 5, possibly indicating a more detailed breakdown of the YOLO v5 model. Then we have Flask framework with SQLite for sign-up and sign-in. Here Flask, a web framework for Python, is used in conjunction with SQLite to implement user sign-up and sign-in functionality. This suggests that the application may have a user authentication system. Then we have user gives input as image or video. User provides input in the form of images or video. This marks the beginning of the user interaction phase. The given input pre-processed and with trained model used for detecting the object. So in this, the user provided input is pre-processed to make it compatible with the trained models. The YOLO v5 and SVM models are then employed to detect objects within the data, input data. And the next here we have the segmented each object and put bounding box with class. Identifying objects are segmented and bounding box with corresponding classes are applied. This step is crucial for visually presenting the results of the object detection process. And the last one here we have final outcome is displayed. The results, including segmented objects and their classification, are presented to the user. This could be in the form of an output display or be a response back to the user interface. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages listed in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. The next folder here we have static. This folder consists of files related to CSS, JavaScript and Bootstrap files. And then here we have app.py file which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. The next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path from here. Open the Anaconda prompt. Type the cd command followed by a space and now just paste the path over here and now hit the enter button. Now just type pythonapp.py and now hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Paste this link over here and now hit the enter button. So here you can see by clicking on the export button you can explore this site. Here it is about the YOLO V5, CNN, SVM plus HOG. These are some of the awesome features of the recognition for autonomous driving. So now just simply click on sign up button. Enter the username, name, your email ID, phone number and your password while doing the registration. Here I have already done the registration so I am clicking on sign in button. Just enter the username over here and the password over here which you have created while doing the registration and now simply click on login button. Click on OK. Here you can see the object detector. This model is a standard implementation of YOLO V5 borrowed from the Torch framework. Files that can be fed to models APG and JPEG. Click on choose file button over here. Here I am choosing this file and now click on open button. Click on submit button. By scrolling down below, here you can see the result for this image. It is showing about the vehicles, that this is the car, these are the three-wheeler vehicles, and about all the vehicles over here. So depending upon the image you will upload over here, it will detect it. So now by clicking on the sign out button, you can simply log out with this. So now coming back to the conclusion part. In summary, the incorporation of deep learning based image recognition marks as a revolutionary advancement in the domain of autonomous driving. This integration leverages the power of advanced neural networks and doing vehicles with a visual perception that closely emulates and sometimes exceeds human capabilities. The core objective of improving road safety is achieved through the remarkable precision and adaptability of these systems. They excel in discerning and comprehending intricate visual stimuli, encompassing elements like traffic signs, pedestrians, and dynamic road situations. The ongoing development of deep learning models, particularly with techniques like transfer learning, ensures a continual enhancement of autonomous driving capabilities. Transfer learning enables the model to build upon knowledge gained from one task and apply it effectively to another, facilitating a progressive refinement of the system's ability to navigate and respond to diverse and challenging real-world scenarios. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.